Robin. I'm a professional agrologist and currently the president-elect on the provincial council. I'm happy to introduce our next speakers. We have Cody Straza and Allison Squires. The next session is titled Implementing Practical Health Techniques on a Large-Scale Prairie Farm. With our guest speakers, Cody Straza and Allison Squires own and operate Uplands Organics at Wood Mountain, Saskatchewan. They've been certified organic since they started farming in 2010 and have been regenerative organic certified since 2021. They grow a variety of cereals, pulses, and oil seeds and have a commercial cattle herd. Their vision is to create a family-oriented, resilient, organic farm that contributes in a positive and significant way to the community. To accomplish this, they have put the focus on how to improve the health and functionality of their soils through techniques such as reduced tillage, intercropping, cover cropping, pollinator strips, compost, and rotational grazing. Cody and Allison were the winners of the Saskatchewan Outstanding Young Farmers Award in 2022 and the national winners as well. Welcome, Cody and Allison.
Well, thank you very much. And thank you everybody for joining us this afternoon. And thank you to the organizers for having us to speak at your conference. We're just going to turn our camera off because of our excellent rural internet. It's actually decent enough, but I think our presentation will come through better if that's the only thing that we're putting through. So. Okay, let me get back to my presentation. Okay, so we're going to tell you a little bit about our farm today. We farm at Wood Mountain, Saskatchewan, which is in the very south central part of the province. We are kind of in that loam, sandy loam area, and on average, they say we're supposed to get 12 to 14 inches, but these last few years have been really anything but average. We've been in the height of the drought cycle since 2017. 2019 was a little bit of a reprieve, but then we're right back into it in 2021, 22. But so yeah, we are on a glacial moraine. It's really rough and rugged land, but it's also very fragile. It's very prone to wind and water erosion and to soil degradation. So in 2016, we started learning about the soil health movement and the 5 soil health principles. And we started implementing these on our farm as quickly as we could to see some of the benefits that they can provide. So we'll go through these kind of one at a time, although there's a lot of overlap and one practice covers multiple principles. So for example, the first one that we're working with is that we're minimizing the soil disturbance. And being an organic farm, our main concern of disturbance is a physical disturbance or tillage. There's also disturbance like a chemical disturbance that like a passive fungicide can wipe out as much fungi as a passive tillage. So, but like I said, we're trying to reduce our tillage as much as possible. And we're trying to do that by reducing the intensity and the frequency. So we're using whatever tillage tool we're using as minimally invasive as we can and only when absolutely required. So this is how we used to do it. We would grow a green manure cover crop, and typically it was a monocrop, either yellow blossom sweet clover or forage peas, and we would disc it into the ground. There was research from the University of Manitoba showing this was the most effective way of capturing as much nitrogen from those legumes as possible and holding it in the soil for subsequent crops. This was typically done in early to mid-July, and then we kept the field fallow for the rest of the year for weed control, moisture retention, and to prepare for the next year. And as we know, that's a recipe for wind and water erosion right there, plus your soil structure breaking down. So one of the first steps that we took was we were using a roller gripper. In those same monocrops, such as the yellow clover, and about that year we also started into peas and oats for a cover crop. We would just terminate it by laying it flat on the ground. So what this is doing, it's first of all, it's reducing our tillage, but it's also providing a cover for the soil. And we'll get into that just in a minute. That same year, we did a bit of an experiment where we had one field left at the end of the year. We split this 90-acre field into 8 different parcels. We roller crimped half, and we used our high-speed disc on the other half of the plots. And one of the things that we found with this is as we reduced our tillage, the length of the fungal strands increased. So we had healthier fungi as we were reducing our tillage. So the second principle is to keep the soil covered, and again, by reducing the tillage, we're keeping the soil covered with that residue from the cover crops. So here's what the yellow clover looked like immediately after crimping on the left, and on the right is about a month after it was dried down. So the goal of crimping is to get a kink on the stem about every 6 inches. It breaks the stem. Well, it breaks the stem without severing. So it's still one long stem on the plant, but it's still anchored to the soil where it's not going to blow away. And when you come through with whatever your next pass is, it's not going to be as prone to wrapping around any shanks, or it's going to be more evenly distributed across the field. People ask, why don't you just mow? And this is one of the reasons, so that it's anchored to the ground. What that, even the dead cover is doing, it's again providing us protection from the wind, but it's also protecting it from the rain and the sun. Now the raindrops, they'll hit the soil and cause soil displacement. They'll cause some compaction. By having that mulch layer on top, it breaks down the force of the raindrops before it gets to the soil, and it allows for easier infiltration. And having those root channels in place also help with that infiltration as well. From the sun, it's providing shade, it's providing cover, and we knew that it would be helping with the temperature mitigation, but we just weren't quite sure how much. So we went out and we got data logging thermocouples. Now you can see on the left one there's a silver probe in the soil. The tip of the thermocouple is 1 inch down into the soil. We put 3 of them out, one on tilled ground, one under roller crimped rye that had already dried down, and one under living yellow clover. And we'd heard that black is bad, brown is better, green is great. But we kind of knew what to expect when we saw the data, but the variance in temperatures just kind of blew us away. So this was all done in late June, when temperatures were kind of getting warm in the daytime. I graphed all the temperatures together, and I was blown away that in here's my pointer, in the black tilled soil, 1 inch down was getting almost 50 degrees Celsius, and then that night drops down to 5 degrees. Under the crimped rye, we reached a high of 33 and a low of 12. And under the clover, a high of 26 and a low of 12. So we can tell that the better the cover, the more we're mitigating those temperature swings. And this is where we're asking our soil microbes to live and to thrive. So it's really important having that cover there. It's just a blanket over the soil, protecting it and insulating it. Third principle is increasing biodiversity. And we have a saying that some is better than none and more is better than less. So one of the ways we started was with cover crops. Like I mentioned earlier, just adding oats to the peas we were using for the plow down. It just adds that diversity to it. Once we got into some of our multi-species mixes, this was in, I'm trying to remember, 2015 or 16. And there wasn't the blending available that we have now. And so we got a pallet of different types of seed, and everybody just grabbed a bag and poured it into the auger of the air drill at the right proportion. And believe it or not, this worked really well. It mixed really well going up the auger. We had a very consistent mix in the field. Now we're getting all of our cover crop seeds pre-blended, and yeah, we'll just load it into the drill and seed it. Often we will have a base of peas and oats, and we'll add in 3, 4, 5 different things on top of that to address some of the soil or some of the concerns that we're trying to address. Another way that we're adding diversity is through intercropping. This is a picture of yellow mustard and kamut growing in alternate rows in a field. So here in the foreground, you can see that the mustard and the kamut are fairly well mixed. There's a good representation of both. Over here in the lower area, the mustard is really dominant. And on the far side of the valley, there's very little yellow. The kamut is the dominant crop there, where it's drier. So in one way, we're mitigating risk by spreading out the plants across different growing conditions across the field. Where it's favorable for the mustard, it's able to dominate and take over. Where it's more favorable for the kamut, it's able to be dominant in that area. We're also mitigating risk through crops marketing. In the fall, we have more crops being able to go to market. We also found that we can achieve more grain coming off the field when it's mixed like this, instead of growing the two halves. If we were to split the field in half and grow half of it in kamut and half of it in mustard, we have found that we can achieve land equivalency ratios of 1.2 to 1.3, which means we're getting 20 to 30% over what we would normally be growing these as monocrops. A key kind of component of this is that we also have an on-farm commercial grain cleaning plant. So it's not a very big plant, but it works great for our purposes. We can separate our intercrops after harvest, and we can also condition our crops to get them into a state where it's very desirable for the buyers. We don't, we get paid for every kilogram that leaves the field, whether it's in high quality grain that's entering the food market, or in chaff and screenings that's entering the feed market. Another part of the diversity is the pollinator efforts we're doing. We're seeding our buffer strips. We're required to keep an 8-meter buffer between us and adjoining conventional neighbors. So instead of just leaving it fallow or even a simple hay mixture, we're putting that to a diverse pollinator mix. And there's been a lot of research, especially out of the United Kingdom, where taking productive land out of cash crop production and having support for pollinators actually yields more than if it had that land taken out of production. Another important one is a continuous living root in the soil. What this does is when you have a plant that's green and growing, it's providing root exudates to the soil microbes. Those microbes, especially the fungi, they're creating, they're exuding glomalin, which is creating the soil aggregates. And those aggregates only last for 2 to 3 weeks, I'm told. And so it needs a constant maintenance. So in the spring of the year and in the very fall, where there's no crop growing, those aggregates aren't being maintained and are at risk of breaking down. So we're trying to keep something growing in those shoulder seasons just to keep our soil structure healthy. Some of the ways we're doing this is we're moving into some biannuals. So we talked about the yellow clover as a cover crop before. You'll see on the right-hand side of the screen, this is yellow clover growing underneath a cereal that's already been harvested, and it's still green and growing and providing those root exudates in the soil. On the left is a lentil crop that's already been harvested. This is taken in the fall. You can see the clover is there growing. And with this disc drill, I just put in some fall rye with it. And again, this was for a cover crop. And it was interesting to see which would take over because both are very aggressive crops, the yellow clover and the fall rye. And we found that the fall rye reached maturity earlier and it got ahead of the clover and it really dominated in that field. So the fifth soil health principle is livestock integration. So we've been grain farmers for many, many years. I grew up with cows, but we didn't have any on the farm up until a few years ago. And in 2017, we had a fellow working with us that he's a real cattle guy, a rancher at heart, and he was running the roller creeper terminating this yellow clover in a drought. And he said, you know, we really need to be putting this through a cow. So we came up with a plan for the following year, 2018. And he, on his own time, brought in custom grazing cattle for this. But on our farm, we put in the cover crops for this. And we put in warm seasons and cool seasons, grasses, broadleafs, legumes, forbs, tap roots, creeping roots, fibrous roots. We were trying to get as much diversity into that as possible while still being high forage value and good grazing quality in it as well. We ran into many challenges that we've given entire talks and presentations on just the grazing aspect of the cover crops. It was quite an adventure, and the takeaway was to be adaptable, to be to have not just plans A, B, and C, but to have plans all the way through L, M, and O, because sometimes you really have to change on the fly. This picture just shows what 100 cow-calf pairs look like. Group type, that's just enough for 1 day of grazing for them. Using electric polywire, we would move them every day. The goal here was to graze the top third of the plants and to trample the bottom 2/3. We've since adjusted that a little bit to a half-half ratio of trampling and grazing. So after 2 years of custom grazing, what would any sane, logical grain farmer do? We bought our own herd of cows. We started with about 300 cow-calf pairs, and we grazed them on our cover crops. I have a video here of moving them. This is from this past year. This is August of 22. This is just a video of Neil, our cattle guy, moving the cows. You can see the lines here, here, and here are where they've been for the past day, and they're ready to move. And after, it does not take long for them to get used to the routine of moving, and they're just as ready to move as you are to move them. So you'll see here, Neil's unhooking the fence, the electric polywire. He's maintaining a tension on it so the cows don't jump over it. And once they find that new paddock of forage, they take to it like nothing. They're out there trying to find their favorite species. Yeah, moving is very quick and easy. It takes about 3 hours a day between moving wires, moving water, and just preparing fence in the next field for the next move. Of course, there's always a few dumb calves that have to be kind of poked and prodded along at the end, but overall moves go really well. So when we do have a good cover crop to graze, this is what we can do. On the left is obviously before we've grazed it, it's mostly a pea oat blend. There's a lot of other little things in there, but that's kind of the main core of it. And on the right is what it looks like when we're moved off of it. It's traveled right to the ground. We get a good termination of it. We don't really have to worry about regrowth. One of the, I guess, advantages, if you look at it that way, is after mid-June to late June, we have real difficulty germinating anything in the soil. So if we don't have it planted early, it's probably not going to grow. But we take advantage of that with our cover crops, in that when we trample it and terminate it, chances are that there's not going to be anything coming up through that. I've never played in so many cow pies in my life. It's been amazing looking at the dung beetles that are in the cow pies. They're burrowing, they're taking that manure, burying it in the soil. And what I found really surprising was we were grazing cows on fields that I don't ever remember there being cows on those fields in my lifetime. And within days, there were dung beetles burying that manure. I'm not sure if they came with the cows or if they were just dormant in the soil for that long, but it was really neat to see that life in the soil just ready to go when the opportunity was there. So this is a bit of a contrast between what we're doing with our cover crops and where we were before we started this venture or this practice. Both these pictures were taken this last December. The one on the left is a cover crop field that we grazed. It's actually the field where we took the video of the cows moving. And the one on the right is an organic neighbor of ours that is using the same practices that we used just a few years ago. And 5, 6, 7 years ago, that's what our fields would have looked like throughout the winter. We never saw our fields blow, but the ditches were brown. And in 2018, we had a field day at our farm, and Jay Fuhrer was here from the Benoken farm in North Dakota, and he did a wind demonstration. He had a pan of loose soil, and at 5 miles an hour, you didn't see any soil leaving, but the catch screen that was white was starting to get soil on it. And he was explaining that those are the finest clay particles with the highest cation exchange capacity, and that's your best soil leaving the farm first. So those brown snowbanks are your best soil from the field. What we're finding is by reducing our tillage and not doing any fall tillage, we're really reducing the wind erosion all through the winter. So in the springtime, we will go and we will work those cover crop acres in, and we will seed right into it. So the time we have that's just bare soil is greatly minimized.
So as Cody's kind of alluded to, a lot of our soil health practices are really focusing on increasing the biological component of our soils. And so I'm going to talk a little bit about some of the other methods that we're using outside of these soil health principles to increase the soil biology component. So I have a PhD, I'm a graduate of the University of Saskatchewan, Prairie, and I have a PhD in environmental toxicology, and I knew when we started farming that I needed to utilize this education in some capacity. So I've really made it a priority of mine to take as many courses as I can to learn as much as I can about the soil. Unfortunately, I didn't take too many of these courses in my university days, but I'm definitely making up for it now. And so one of the more foundational courses I've taken is the Soil Food Web course series, and I took this course series in 2018. And as part of this series, I learned all about the soil food web. I learned how to make compost tea, and I learned how, most importantly, to use the microscope so we can do a lot of our own soil biological assessments right here on the farm. Because something we realized really easily, really in the beginning of our journey, is that you need to be able to monitor your soil to know what you're starting with, and then again, what needs to change. So we've made establishing a benchmark on our farm a priority. So I performed this benchmark assessment of soil biology across our whole farm in 2018, just after taking this course. And I actually found a few surprising things. I found that we actually had a higher fungal ratio than I expected. I assumed with all the tillage that we had been doing that our fungal ratio would be quite low, and granted it was not where it needed to be, but it was definitely higher than I was expecting. I also saw some of the really higher beneficial organisms, such as bacteria feeding nematodes and even some microarthropods, which were really exciting to see under the microscope. But unfortunately, I didn't find any of the mid-level soil food web creatures, such as the protozoa. And I actually had a really low diversity of bacteria. So I had a lot of bacteria, but the species within that population weren't diverse enough. So since completing this this baseline assessment, we've really shifted our focus to adding these organisms back into our system to help complete the soil food web. So I just want to take you through some of the analyses we did back in 2018 that kind of spurred us on this journey. First thing, of course, is an organic farm. Weed pressure is a big factor in determining our yield potential. So I really wanted to look at what the soil biology of the weed patches were compared to the healthy crop patches within a field. So I took a intercrop that we had of lentils, mustard, and oats growing in one field. And what I did is I took some soil samples within the field, and then I took some soil samples within the thistle patches within the same field to try to compare them. I really found some surprising things. The first thing that I noticed is that the field, so where the crop was growing, had 42 times more beneficial fungi than the weed patches. So that was really encouraging. We knew then that the fungi were playing an important role in our yield potential. And then we also found that the weed patches themselves, so these thistle patches, ended up having 600 times more, quote unquote, bad fungi than the field did. So when I'm talking about beneficial versus bad fungi, something that we've learned is that there are different species of fungi in the soil, and some of them are indicative of healthy soil conditions. So they thrive more readily in well-structured, aerated soils, and some other species thrive more readily in poorly structured or anaerobic soils. So when I'm talking about beneficial versus bad fungi, that's what I'm talking about. I'm talking about the fungi you find in really well-structured soils versus the fungi you find in less healthy soils. Another analysis that we looked at is we wanted to compare two fields growing the same crop type side by side, but we sampled them separately. So the crop type we have here is kamut, and if you don't know what kamut is, it's a heritage grain. It's also known as corzan. And so we've sampled two different fields side by side of this different crop. And so what we found is that the first field we sampled actually had 1.5 times more of this beneficial or aerobic fungi, and it also yields 55% more than the second field. So this again is reaffirming our knowledge about the importance of the good fungi or the good soil biology and how that relates to yield potential. So knowing all of this and completing our baseline, we're then going to say, okay, well, how on earth do we go about adding these biological organisms back into our soil and try to speed up the process of increasing our beneficial soil biology? So like I said, I have taken a lot of courses. And one of the things that I latched on pretty early on in our journey is composting. And growing up, when you hear about compost, you think about the little kitchen bin that you have, that you put your kitchen scraps in, and you turn it every now and then, and it's usually super smelly and gross. And so that's the kind of the perception I had of compost when we went into this journey. But I soon realized that there's a good way to produce compost and a not great way of producing compost. So I knew that there was potential for us to really make this an important part of our farm. So as I've said, over the past 5 years since we started this project, we've increased the amount of fungi in the soil and we can now see protozoa in the soil. And I attribute that a lot to a lot of that reasoning behind adding this compost. So compost will increase the number of organisms in the soil. It has the potential, because of that, to increase your percentage of organic matter in the soil. Better organic matter means we're increasing our aggregate formation or bettering our structure, which increases soil pore space. It leads into better water and air infiltration, and of course, that translates into healthier plants and better crops. So I don't need to tell any of you guys this knowledge. Obviously, you're better equipped to explain this than I am. But when we looked at healthy soil versus unhealthy soil, we saw these different makeups of soil water, soil air, mineral matter, and organic matter. And we learned, of course, that unhealthy soil has less soil, water, and soil air space than healthy soil. So that's what we're aiming to do. We're aiming to change the structure of our soil through the addition of soil biology. So I have a couple of pictures here. We make no claims at being perfect or having it all figured out, but I can tell you that on the picture of the unhealthy soil I have there, that's what our soil typically looks like. And we still have a lot of our fields that look in that way, and you can see it's very platy. It's got this huge compaction layer. It's definitely not a healthy looking soil. It's and the color of it is awful. And then on the other picture is a picture of what we like to see of healthy soil. And unfortunately, this picture is not from our farm, but I use it as a way of measuring the goalposts. This is where we want to get to. And so we know that we can get there using some of these techniques. So when I learned about composting, of course, there's different types of compost, but for the purposes of this talk, I'm just going to go into these two different types, aerobic and vermicomposting. Just simply because this is our main form of composting in our operation, and I honestly don't know a whole lot about the other two kinds at this point. So the first type of composting that I'm going to talk about is vermicomposting. And the reason why I do this is because this is the first type of compost that we started to produce on our farm. We're a busy farm, we're a busy family, we've got 3 little kids, and I needed a way of producing compost that wasn't going to take up a lot of my time and efforts, because I didn't have a lot of time to dedicate to this project, to be honest with you. So vermicompost is a really easy way to do it. There's no turning involved. You kind of just set it and forget it type of thing. Our budget at this time also wasn't super healthy to do this project. So what I'm showing you here is pictures of our setup, and we wanted to set up a flow through vermicompost bin, so we could be adding composting materials on worms to the top of the bin, but then harvesting that finished compost off the bottom of the bin. So this is just a really simple setup. We used a set of shelves from our local hardware store, built a frame within that, added some puckboard on the inside to make it moisture proof. And then you can see there that the grate on the bottom means that that the compost can be harvested and fall through in the bottom. And sure enough, once we harvest that bottom layer, we're getting these bins of finished vermicompost. So this bin was set up in 2018, and it's still going strong today. I have it in, we have a soil biology lab set up in our shop here, and I use this vermicompost in many different ways. One of which is to make really good active compost tea. So compost tea is not like compost extract, if you've heard both of those terms. The difference is compost tea is an active, reproducing, biologically active solution, versus compost extract is more like a compost wash. You're just washing anything off of the compost. So compost tea, the basis is just you're washing the compost, like I said before, but then you're adding different food stocks to keep the organisms within the tea actively reproducing. So you have the ability to dramatically increase the density of the organisms in the solution going forward, which really makes it for a very powerful way of adding a lot of organisms with a very small amount of tea. So how we make our compost tea on our farm is we start with our good quality vermicompost. You add non-chlorinated water, that's super key. On a farm here where we are, obviously chlorination is not part of our water treatment system, so that's not a huge issue, but you want to keep it super aerated. So again, you're creating that aerobic environment for those beneficial organisms to reproduce within. And then you can add a whole different list of foods to feed those organisms. And depending on what food choices you make, you can really impact the potential for different parts of the soil biology to reproduce better. So for example, what I mean by that is really simple sugars like molasses or white sugars that you can add to your tea. Well, those are simple sugars that bacteria love to eat. So if you want a highly bacteria laden compost tea, you'll add some of those simple foods. If you want a more fungal tea, you're going to add more complex foods like the fish hydrolysate and the kelp and the seaweed. And those types of foods, fungi love to consume. So those are the ones that are going to thrive in that system. I really learned a lot about using the microscope to assess our soils, but I also use a microscope to check our compost teas and extracts before I use it. When we first started doing this kind of stuff, it seemed a little bit hokey to me. And I was actually a little bit worried that I would be adding things that would harm the soil versus regenerate it. And so I've really made a focus of being able to identify some of the more beneficial and some of the not so beneficial organisms in these brews, so that I know that I can say for sure that I'm not adding anything into our system that we don't want to add. One of the main ways we use these compost teas is actually with a seed coating. You see me standing there by the auger with our really high-tech seed coating system. But it's really a simple, really cost-effective way to add some biology into the soil. So what we do is we coat all of our cereals and our pulses with our compost tea brews before we seed the seed into the ground. And all it involves is, you see there, I'm holding that hose. We've got a barrel of our compost tea lifted high in the air with the tractor, so it's all just gravity fed down. And it's just a very slight amount of tea to coat the seed. We aim for about 5 to 7 liters of tea per ton of seed. So you're not talking about a huge volume of tea that's required. And this really wasn't a huge leap for us anyways. We use our peat inoculant as part of our strategy before we seed our pulses. So we were coating our pulse seeds anyways with this inoculant. So it was very easy to then, instead of using water, we just used tea as well. And it was really an easy transition for that. So what we've learned though is we learned that we need to coat our seed before we add it to the drill. And the reason why we need to do this is to prevent caking within the drill and plugging the drill lines. We learned that the hard way the first year that we did this, and I'm always in trouble for it. But so now what we do is we coat our seed and we move it between 2 trucks and then we add it to the drill. It's just a little difference that really makes life a lot easier when you're using these techniques. So why else would we do that, right? So again, I'm asking that question all the time on the farm. I'm not going to do anything on our farm that I don't think is going to be worth my time and effort to do so. And so I, of course, ran a little tiny experiment here. I just used some plain non-tea coated seed, and I used some coated seed. And I was able to see a really distinct difference between germination and vigor. So you're seeing here on the bottom, the picture of the seeds that I had coated with the tea and did a little germination test in the paper towel. You can see they're way further advanced than the seeds that we didn't have coated, but did the same germination test at the same time. So that shows you really visually how much of a difference coating the seeds in this biology makes. So the other type of compost, like I said, that we utilize on our farm is thermal compost. Now this is a little bit more labor intensive and it's definitely not for every farm to do, but it's something that we've really seen a great benefit from. We were able to source a lot of our starting materials like the manure and straw pack from a local ranch when they were cleaning out their corral systems in the springtime. And so it was a locally sourced manure, and we borrowed this amazing compost turner from some friends of ours. And because again, I had taken these courses and I knew what I was doing, I was able to transform this really gross looking manure pile on the top picture there to some really, really nice thermal compost on the bottom picture. You can see there that we're adding water as we're turning it because it's really important to keep the right moisture content so that the biology continues to thrive in these piles and continues to break down the starting material. And so you'll turn these piles usually about 5 to 6 times before you get a finished compost product. And at the end of the day, it's really been something that we've been using ongoing on our farm. So I have a video here just to see if you've never seen a compost turner going. It's a little bit jarring. It does tend to flip things around. And of course, this is the first time that we were ever using one ourselves. So we were learning as we went. And you'll see there that at the end of the video here, you see that bunch of steam that's coming off the pile as we're turning. That's telling me that the pile's heating up adequately. It's telling me that the biology is active within the pile and that it's turning into really great compost. So I'm monitoring temperatures and returning the compost on a regular basis. It took us about a month and a half to finish 3 large windrows of compost. So it's a high intensity, labor intensive thing, but for a very short time. And for those machinery geeks in the audience, I always like to put this picture of the turner just because it's really interesting to look at. I've never seen one up close before we borrowed this one. So it's just a huge drum that rotates and turns the compost as we move through the pile. So how do we use this compost? Well, we don't use it to brew teas, but what we have done is we've been applying it directly to our fields on site. And what we've seen is that we've seen a lot of great benefits from this. And it doesn't take very much. It's just a sprinkling of compost across the field. And again, it's more about quality versus quantity with some of these techniques. And this is a field where we applied this compost. I think we applied it in the fall. And so it overwintered under the snowpack. And in the spring, we went through, as Cody's mentioned, our one pass of tillage occurs in the spring to prepare the seed bed. And at that time, the compost was incorporated directly into the soil. And we have seen a shift in biology in this particular field. It was one of our weediest, one of our most heavily infested fields of Canada thistle. You could clearly see the Canada thistle patches from the road at this point. And actually in the foreground there is a Canada thistle patch now that I'm looking at it. So it was really definitely a heavily infested field. We've applied this compost and since then and done it, of course, proceeded through all of our grazing and other soil health techniques that Cody's gone through. And now I can honestly say you cannot tell where the thistle patches are from the road. So we have neighbors that have driven by and asked us bluntly if we have sprayed the field because they've seen so much of a difference in the decrease in weed pressure prior to us starting all of these different techniques. Well, I really appreciated the previous talk before the lunch break because it really speaks to the reasons why we're doing what we're doing. We farm, as Cody mentioned, near Wood Mountain, which is right in the very bottom part of the area of the Palliser Triangle. And us Palliser Triangle farmers are a hardy bunch, I'm learning, because our drought system started actually in the top there. You'll see a map from 2017. That, I would say, is the first year that we really started to enter a drought phase in our area, and it hasn't let up since. So we've been in drought or severe or extreme drought since 2017. We started applying a lot of these soil health principles in 2016, so not great timing on our part, but how are you to know what the weather is going to do? So I wanted to go through some of the things that we've noticed that have improved on our farm despite being in constant drought since we started these techniques. Like I said, we do a lot of our soil health measurements on farm. I also take soil tests, like physical and chemical soil test samples, and I send them away every fall. So we're constantly sampling and measuring our progress. Over the last decade, I can say that we have increased our soil organic matter across the farm by 1%. We've also noticed that we've had much better water infiltration rates. So we're noticing that we do our in-field water infiltration testing. We notice that the amount of time it takes for that second inch of water to infiltrate is much less than it used to be. It's still not great, but where we used to be an hour or more, now we're measuring it in about 20 minutes. So it's progress, and it's something that's measurable and encouraging. We've also seen our soil biology shift. So as I mentioned before in the beginning of my part of the talk here, we used to be predominantly bacterial. And so what that means is that a healthy soil for crop production, you want a ratio of 1:1 bacteria to fungi. So we used to be at 0.3. And now, since we started, I've done some testing a couple of years ago. I've noticed that we've become more fungal. We're now up to a 0.7. So we are making real measurable progress in shifting the biological component of our soil. Cody's talked about how we're using rotational grazing now. Some of the experimentation we've done around that is that we've tested we measure calf weights on pairs that we're raising on regular pasture versus pairs that we're running through our rotational grazing program on cover crops. And we have weighed calves before and after grazing, and we can say that we have found a 20% increase in calf weights on the calves that have gone through our rotational grazing program versus calves that have been strictly on pasture. So that's a huge economic benefit, as well as, of course, the soil health benefit of using that rotational grazing practice. We've also noticed over the course of the last 5-6 years that we're increasing the protein content in the cereals. We used to have trouble meeting the specs of our buyers in terms of minimum protein amounts, and now we're always meeting them, if not exceeding them. So it's a lot easier to market our grain as much higher quality than it used to be. And this is a little bit anecdotal, which is why I put it at the end. But we heard last year that through the crop inspector that came to our farm, that the yields that he's recording in our farm is higher than the yields he's recorded in the average farm in our region. So again, I don't have any data for that, but I mean, it's still kind of encouraging to hear that kind of feedback from people. Organic farm, sorry, Cody. Yes, sorry, we're comparing organic farm to organic farm, obviously. Yes. So that's kind of, I want to leave on this slide because I think it's really important when we talk about soil health and implementing some new techniques. I know as a farmer, we're always looking at the bottom line, and we're not willing, it's not really easy for us to start changing our practices and investing a lot of capital and a lot of time into doing that if we can't say at the end of the day that we're actually getting some economic benefit back from that. So that's why I put this slide up there. The end of our presentation, and I think we are within good time to accept some questions if anybody has any.
Well, thank you very much, Allison and Cody. With that, we can run through some of these questions here on the page. Let's see, I'll just go to the top of it here. So Ross McDonald says, congrats on being awarded the Saskin Canada's Outstanding Young Farmer. The USDA has a branch known as the NRCS, which has been extremely important in implementation of soil health concepts. Do you think Canada's farmers could benefit from a similar service?
Absolutely, Ross. Yes, I think so. I think, you know, and if no one's heard about this, the SARE as well, they have great soil health resources as well. I think the US is far and away ahead of Canada in some of their extension and resources for producers.
Is it a balancing act between living roots for aggregate stability and moisture conservation, especially in the brown soil zone?
That was a lot of that experiment that we did with the tillage and the roller crimping side by side in that one field. And that is one of the things that we were measuring is because moisture is always a concern for us. And well, Elsa, do you remember exactly where we were at? But
Low.
well, low and lower was how they came out. But we did see more moisture in the cover crop. Sorry, they're both cover crop in the roller crimped plots than in the tilled plots. Even though that clover is still living for a while it's drying down, it's transpiring, but the tilled fields are evaporating. So, and you're also losing, like you're bringing up some of that moist soil, letting it evaporate. They're both losing moisture, but the tilled fields are losing more moisture. I hope that answered the question.
Paige Kennedy is asking, can you give some additional info on your cover crop management? Do you have any insight to share from your experiences on cover crops and impact on the soil biology health, aside from the physical soil traits like improved aggregation? And how long have you been cover cropping?
Well, we'll start at the end. How long have we been cover cropping? As long as since we've started in one form or another. As organic farmers, that's our soil building year, right from even a more traditional organic farmer usually has a green manure year where you grow a legume and you disc it in. So we were used to the idea of taking a year out of cash crop production to do that. It was basically for nitrogen replenishing and some weed control. But when we started getting into the more diverse cover crops and the roller crimping, it was just kind of a natural progression. With the different species, you're getting different root exudates that support different types of microbes. I'm going to stop there and let Alison take over because Alison's more on the microbe side and all that. Yeah.
Well, yes, we've seen, and I think I didn't really get into it so much with the data, but we have seen an increase in our soil biology amount as well as diversity by using cover crops. And the more diverse our cover crop mixtures are, of course, the more potential we have for increasing the diversity of our soil microbes. So different microbes thrive around different root exudates, and we're getting to the fringe of my knowledge, but I think it's been shown that increasing the diversity of your cover crop mix will definitely increase the diversity of your soil biology, and so that's the reason why we've been doing what we've been doing.
So with that first round of livestock integration, you mentioned the need to adjust your plans frequently. What were some of the lessons on what worked and what didn't?
Oh, that's a can of worms.
Oh boy. Okay, so our first year we approached this like a bunch of grain farmers, and we had 400 acres that were all ready to graze at the same time. So one of the first lessons we learned was staging out the cover crops, and you can do this with different seeding dates. Like I said, peas and oats are often the core of our cover crop blend. You can add different things into it that support different maturity, like a longer maturing things like proso millet we're just getting into. if we ever get back, okay, and then the other thing is to shift your plant species. If we get back into a wet cycle, I'd be really interested in doing some grazing of corn, sorghum, Sudan, some of the long season C4 grasses that maintain their quality after freeze up. So we can stretch out the grazing on more acres by using some of these things. Some other lessons. When it gets hot, you're making lots of trips with the water truck. We don't have a lot of water infrastructure in our fields, so we were hauling water every day. And that first year, we had a 1,200 gallon tank in the back of a 3-ton. We were when the weather hit 40 above in 2018. We were making 3 trips a day, so that was a lot of time commitment. We've gone to a semi-trailer pulled by a tractor. 1 trip a day is usually enough. Absolutely. Well, we've learned a lot of lessons, but that kind of a few of the highlights.
So did many of your fields that you are now grazing cover crop on have fences around them before? And if not, what was the process like to decide to fence those things?
Fence is super important. Otherwise they end up in your garden.
Yeah, that never happens. I'd say a third to half of our fields have a perimeter barbed wire fence around them. And those that don't, we use a perimeter of a temporary electric. We've been pretty lucky and fortunate that our cows are fairly well trained to electric fence, and we are able to keep our cow-calf pairs in with a single strand of aircraft cable. We were using a high tensile wire, and that is a real pain to work with, especially when you're rolling and unrolling. And poly wire, you can get 1/4 mile on a reel, and it breaks easily if deer go through it. So a couple years ago, we discovered aircraft cable. It's just regular woven steel cable that's a 1/16 inch. We got it from an electric fence supplier that stocks it on 3,000 foot rolls. So it's more than enough to do a 1/2 mile with 1 spool. We made our own spools and rolling and unrolling structure for the back of the quads, and you can just zip out a 1/2 mile, pound in the posts. Just easy peasy. But no, we can graze stuff. Like I said, it's never had cows on it in my lifetime. They were there for 2 weeks on the quarter section and out again. And we do put some wood posts in at the corners so that we can tighten against them. But other than that, there's very little infrastructure left when we leave.
Okay. How often do you seed your cover crops? Is it every 2-3 years?
We have a bit of an adaptive rotation. It used to be a very structured 4-year rotation that we would have a cover crop every 4 years. We've gone to more adaptive where looking at the field, if after 3 years it's still doing really well, producing well, no weeds, we'll stretch it an extra year, maybe an extra 2 years. Or on the flip side, if after 2 years it's a bit of a mess, we'll short circuit that and come in with a cover crop the next year. We're starting to get into a 10-year rotation with 3 years of established perennials that will graze in the middle. And then in theory, 3 years of cash crop, a cover crop, and another 3 years of cash crop.
And the reason why that works for us is because we have the cattle, and we benefit that we have the economic benefit of having our own calf sales and our own cattle sales. And so we're able to introduce those perennials right in the middle of our 10-year rotation like that and still gain economic benefits from that land base during that time.
And the perennials add just a whole other level of root structures. Like you can get a lot more tap root action out of perennials than you can out of the annuals. Also, weed suppression control. Alfalfa will do one heck of a number on Canada thistle patches. So it adds another layer of awesomeness to our cover crops.
Technical term.
Okay, so with your
Very scientific.
Sorry.
with your thermal composting, have you ever had problems with introducing weed seeds into your field?
That is an excellent question. It's something that I was worried about when we first started, but the idea is behind thermal compost is that it's heating up to such a degree that it's going to kill any weed seeds within the compost. So we heat our piles to a minimum of 165 Fahrenheit before we turn, and doing that 5 or 6 times adequately heats the entire pile high enough that we're killing any weed seeds or any other parasitic anythings in the compost to kind of ensure that it's free from any kind of things we don't want to actually put on the field. That's a great question.
Okay, so then how have you found accessing capital to fund these changes on your farm? Was the process like integrating, how was the process like to integrate these past practices on the farm's bottom line?
Again, another great question. And you'll notice a lot of these practices are things that aren't very capital intensive. The compost, the vermicompost, our bin, like also detailed, was cost us under $500. The materials going into it are more or less for free. A lot of the soft and the nitrogen, the green sources are either things that we find around the farm or kitchen scraps. The brown, again, is stuff that we find on the farm. Like when we bring the combines into the shop, and also there sweeping the choppers off, catching all of that loose chaff and straw into a barrel, and we use that throughout the winter as a carbon source for the vermicompost bin. A borrowed compost turner. We did write checks for the manure coming in. It was a fairly good deal, I thought, but basically for the cost of cleaning the corrals, we got the manure. So we didn't actually pay for the manure, we paid for the corral cleaning. So it was a win-win there with us getting the manure and the neighboring ranch getting their corrals cleaned.
So do you guys use some specific soil tests on your farm, or do you do soil testing on the farm yourself?
We do both. We do we didn't get into this, but we hold a higher level certification called Regenerative Organic, and it's a thing out of the States. It's just starting to come into Canada now. And as part of that certification process, they do require a certain suite of on-farm soil testing to occur. And so again, things like water infiltration, we'll do that during the growing season. We'll do slate tests to measure aggregate stability. I don't know. I always use the microscope to assess every fall. And what we've done, because we're managing such